Hey guys, it started, right? I think it has. Whatever be the case, we are going to be talking about Git as a software engineer today. So, the reason I've chosen this title as a software engineer is because a lot of us, when we join an organization for the first time, or even if we are doing our project for the very first time, we want to know about what's the best way to do a project. I think what happened with me, my personal experience was when I was in second year college, I wanted to do a project with one of my friends, and we had a lot of project files. So whenever we would change any file, we would actually send an email to each other. So let's say there's 50 files, you make any changes, you would send it to your friend, and then they would have their own changes locally. So there used to be a mess. Like, you would take some of the changes over here, sometimes there would be a conflict, and you would manually remove these things. So this was the way in which we did our project. Now, this is horrible. Okay, this sucks. Instead, you have a software called Git, which does everything for you when it comes to version control. All right. Is there anyone over here who still uses emails for doing their projects? I'll take that as a no. No. So, firstly, I'll just start this at 9:05. So till then, set up your computers. I'll just show you what I'm going to do. I'll switch off the webcam. You can see I'm over here. I go to my GitHub directory. I will make a directory. Let's say I'm starting a new project, okay? And you guys should do it too. I mean, open up your terminals. I'm giving you 3 minutes. Take some coffee, whatever you like. But start doing this, in your own local computer so that you get to know what's going on over here. So make directory sample project. Yeah. Now I have a sample project directory. So I'll just go into that. CD sample project. Perfect. So now I'm inside my sample project. In fact, that is completely empty, as you can see. But if I do a git init, in fact, let's just wait at this time. 9:05, guys, grab your coffee, open up your terminals, set things up. Whichever directory you want to make your project in, that's where we will go. And if you're watching this after the live session, you can jump directly to the 5th minute and you can figure out what's going on. But I'm just going to give our live people a little time, to set up. Okay, till then I'll just take a few questions on the chat. There's 2 minutes for that. Okay, Akash Gupta says, what is inside system design course? Oh god, you got a sneak peek into this. This is supposed to come out in some time. That's a interesting leak. That's the reason why you should use a VM, for this kind of stuff. But yeah, system design course is quite interesting. I have a set of videos which are going to come up, and you'll get more details in maybe a week or something. Let's see. Most likely in a week or two, the course should be out. So good catch over there. Okay, there's 1 more minute. Is there any question you guys have on Git or in general software engineering? After which we'll start. Ashwin Tantri is asking, branching samjha do. Branching to samjha dunga, yes. There's going to be some talk about what a branch is, and hopefully the concepts that will be talked about today will be something that will make Git very clear to you. Okay, Shubham Gandhi, please talk about open source contribution too. Thanks in advance. That's a very vague question. You can probably frame it better. And you have, I think, yeah, too bad. You're spamming the board, so I'll have to ban you. I'm such a positive guy in general. But okay, 9:05, guys, we are getting back to the coding bit. Perfect. So I'm assuming that you guys have the branch open. So, I mean, your terminals open. And what I'm going to be doing is I'm going to be making a Git project. So I have a project with me. Currently it has nothing. Okay. And what I'm going to do is I'm going to init it. I'm going to tell Git that, hey, this is a Git project, so please look into it. So the command for that is git init, right? And boom. So initialized an empty Git repository. What did this do actually? So ls-la. Okay, we have a .git file, but if you want to see all the directories in your current folder, you can do a du-c. Okay, so once you have typed in git init, do a du-c and you'll see this. So your project has no files except in the .git folder, and you have no objects over here. So this is quite interesting. What is Git after all? Git is I'll just type that over here. It's a content-addressable system, right? So content-addressable system is what Git is. Basically, it has a bunch of content. It has addresses for those content so that you can link to that content. And there's a system. So behind all the madness, there is some order. So you can actually view the content, right? Okay. Now, content-addressable system, you saw that there are no objects. So what content do you have? Nothing. You have nothing right now. So you have to actually make a file, right, to get something on Git. So I'm just doing this touch coding.txt. So I made a file coding.txt. And now I'm going to be writing something in this coding.txt. I love coding, let's say. Okay, now if I just print this out, it's writing I love coding. Okay, so it's a file, it has I love coding in it. But the important thing is I want to actually add this to Git. So git add coding.txt. This is the command to add files into Git, basically telling Git that, hey, this is a file I want you to take care of. Okay, so that's how things work here. Boom. Now let's do du-c. It's going to tell you what are the files which are visible. Okay, interesting. So earlier, if you remember, the objects directory had nothing inside it. Now it has something inside it. It's got these 8 characters, or I'm not too sure. I think it is 8 bytes. Yeah. So, but the 8 bytes are not coming from the info or the pack folder. They're coming from here. So what is this thing? Let's ls that. And you're seeing this long number. What E6 9006551 so on and so forth are it actually is a hash. Okay, so when we say git add, what Git did is it went to coding.txt, read the contents of the file and hashed it, as we'll see now. So cat.git objects E6, inside there's just one file, so I do this, and inside you should be able to see the data of the file that we just created. Okay, I'll give you guys some time to catch up, but what I've done till now is I have created a project, I have added a file to Git, and I can see that there are certain objects inside. Okay, and boom. Oh, okay. So once I did cat basically prints the contents of a file. This garbage came out, like this makes no sense. Okay, xk is not what I wrote. I wrote I love coding, so that is weird. Have a look over here. I said I love coding, and in fact I cat the file earlier and it comes to I love coding, but over here there's garbage. So basically what's happened is Git is actually compressing the file using something called a zlib library. Okay, and I'll prove it to you by using this cheat sheets of commands I have here. So basically it goes printf the cat file, and what is it again, E6, right here, E6 the file, and over here what I'm doing is I'm uncompressing the file. Basically this entire command, what it is doing is it's taking the file, which is this one over here that we just created, and then the compression is going to be decompressed, right? And you're going to be able to see the contents of the file. So as you can see over here, it's blob 14 I love coding. Quite simple. and quite useful actually, because if you understand what's going on inside Git, it's not magic. What Git is doing is every file that you create, it's actually compressing that file and storing it, so that if you write really large files, the amount of memory used by you will be less. That's the basic idea. But it just didn't store I love coding, it also stored this stuff, blob and 14. What are these things? Look at 14 and look at I love coding. The length of I love coding, which is I space 2 over here, plus 4, 6, 7, and then 10, and then you have 3 more over here. So you have 13 characters over here, and the blob is of 14, length 14. We'll see why this is the case, but it's saying that the file length is 14, and the type of the file is blob, which means it is a binary large object. Basically, it is a bunch of random binary characters. That's what it's saying. Okay, so now I have uncompressed this file and I have shown you that this file is nothing but just a gzip compressed file. So what I'll do is Git gives you a few plumbing commands which actually let you read these files. So git cat file, e6 is the file I want to read, and then there's 90 after it. So, oh, ignore that, that was a wrong command. Minus p tells you pretty print. Okay, so I love coding is the content of the file. If you want to see the size of the file, 14, so minus s. So Git is doing nothing great, it's decompressing this file and then telling you that the size is 14 over here. The cat file, I mean the file itself is I love coding, and the type of the file I can do with a minus t, which is blob. Okay, so this bit is simple. It stores 3 things: the type of the file, the size of the file, and the contents of the file. Okay, and I was talking about this entirely like ridiculous number, this huge number, E690, so on and so forth. This is actually the SHA-1 hash of this file content. So let me just show that to you. Echo minus E, so this is going to print the thing. We said I love coding, right? So I'll just print that over here. Okay, and I'm going to take a SHA sum of this. Right, guys, are people following along? Like, are you guys able to view things properly? Okay, there's some complaints on a lot of spam coming in the chat. Time to ban people, time to purge people. This is my favorite job, actually. But I'll just give you 30 seconds, guys, to catch up with what's gone on now. I have just created a file. I wrote into that file. I'm now kind of inspecting what's going on inside the Git data structures. Okay, Ali Solanki, that's a really good comment. Awesome, like you guessed it. I don't think you guessed it, you know it, so that's great. Okay, so let's take the SHA sum, and you get a completely different SHA sum. So this is not what we have. So it's not just taking the contents of the file, it's taking the contents of the temporary file that it has created, or rather of the file that it has created. So I say echo this stuff, and this should work. So the SHA sum of this should be equal to E690, so on and so forth. Okay, boom, and it's not. The reason for this is because I said there's 14 characters, right? And we just counted 13. So there is a null character over here. Okay, it starts with a null character of the file. So SHA sum now will be correct, E690. And basically what Git is doing is it's taking this entire SHA sum, using the first 2 characters to bucket the hashes, like bucket the files, and the rest of it is an identifier inside that. So if you know about hash maps, that's exactly what it's doing in your local memory. Okay, guys, have a drink while you're doing this, because I mean water while you're doing this, because it's going to be a pretty intense thing. So you need to learn quite a few things very quickly if you have not worked with Git earlier. Okay, are things making sense till now? Yeah, between branches. Okay. Do you have any doubts, guys, on this? till now. What we have done is we have just seen that a file in Git is nothing but the identifier of the file is nothing but the SHA of the contents of that file, and the contents itself are the type, the size, and the text inside that file. Okay, so whenever you write code, technically what you're doing is you're doing this, the contents here, and then it's going to be a blob and of size 14. Perfect. All right. So let's move on. We have had a git add till now. We can also commit the stuff that we have done right now. So we have I love coding. We have added that to git. Now we want to commit whatever we have done. So git commit -am. The message will be, let's say, first commit. As a software engineer, of course, I'm great at naming. Okay, so we have a commit. We have one file changed, one insertion, I love coding, in the coding.txt file. What this did is it created an object called a commit object, and as we'll see in this du-c, yeah. So earlier we had E6 with us. Now we have two more objects, 1.4 and E2. Okay, that's quite interesting because the number of objects you had initially were just one file, but with one commit you had two files created additionally. So what are these files? Let's see. So firstly, I want to actually print out this file 1.4. So git cat file, git objects 1.4. Yeah, but as you can see, I need to actually remove the bucketing of this file so that we can read it. So -p 1.4 is going to be the commit itself. Wonderful. So you can see in the commit there's a tree object. This is actually the root directory. Okay, a tree is very similar to Unix directory. It's actually even simpler than a Unix directory. And E2AD is going to be that file. But the author is me. The committer is also me. Okay, wonderful. So what I do here now, I can just print the size of the file. So git cat file -s 1.4 E0, and this will be basically the size of text of the file. Okay, and the type itself is a commit object. Okay, and what about this cat file? I mean, what about this tree? So let's try to see that also. So print that. I want to print the tree. The tree has a blob in it. Okay, E690 is the file we created. So the tree is saying, hey, there's a file which is of type blob, E690, and its name is coding.txt. All right, guys, is this clear? What we have done is we have created a structure, which is, I'll just show you over here. You can run through the commands for now. I'll just open up the browser and add this explanation diagram over here. So that's what we are doing. If you have any doubts, then let me know. There's a lot of commands I've just entered, so you might have some doubts, and I will be answering as many as I can. Docs. Okay. Okay. Oh God. So this is the structure of the file that we have. You can see that there's a tree, which is the root directory, the topmost tree. It has directories inside it. So those are subdirectories in the Git project. So you might have, let's say, the top directory being your project name. In our case, it is sample project. Inside, you might have a subdirectory which says all the config files stay here. So inside the config files, you have file 2, file 3, file 4. And in the coding file, let's say the one on the left, the coding directory, you have just one file. So that is how the structure of the directories and the files are. It's very similar to Unix, actually. But the commit itself is actually pointing to the root directory of your project. So whenever you say git commit -am and you actually commit the what you have, the local repo, what you do is you make this new commit object which points to a tree, as we can see over here. Right? If you go over here, you can see that the commit object is pointing to e2ad. And what is e2ad? It is, I'll just pretty print that. So git cat file -p. Yeah, it's just the directory we had. Actually, it's e690. No, e690 is the blob entry we have. So e2ad is the tree that we have. Yeah, I'll just prove that to you by saying what type is it. So that's a tree type. Okay. So till this point, I think things are quite clear. What we have done is we have gone into the .git folder and we have seen what are the things that it contains. So Git itself is like a database, right? It has objects inside it. Those objects have particular sizes. It has some sort of hash bucketing, which is based on the contents of the file. The file contents themselves are zipped. That's it. And there's a structure to this directory. The structure is commit object points to the root directory. The root directory contains the information of which subdirectories and subfiles it contains. And then as you keep going down in the leaf nodes, all of them will be files. And that's basically your Git project. Perfect. So this is what we have in Git. Let's head to the next section. Some interesting questions I have for you. I'll just answer. I'll wait for the answers in the comments. If you rename a file in Git, does that change the contents of the file? Like the first file that we played with was, I think, E2, right? E6. E6 is the file. So E690, right? I'll just do a git cat file -p E690. Okay, I love coding. What if I change the name of this file? So I have in my project coding.txt, I say move coding.txt to let's say java.txt. I don't really know. Let's say youtube.txt. Yeah. Okay, now I do a ls. I have youtube.txt. Now I say git add youtube.txt. What do you think will happen to E690? Will it be deleted? Yeah, perfect. I have some good answers in the comments. No. The SHA does not change, right? Because the contents of the file have not changed. The type of the file has not changed. The size of the file has not changed. So it won't actually make any difference. So let's just confirm that du -c. We have in the objects E6 still existing. And I had done a pretty print, right? Let's do that again. I love coding is still there. But there are some changes. Have a look at 1.4. Right, earlier, we still have 1.4. That is quite odd. Okay. But the name of the file has changed because we haven't actually committed the file yet. So the tree and the commit has still not been created. That's the reason why no other files have been added. So I'll just do that. Git commit -am renamed file. So you see one file has changed, 0 insertions, 0 deletions. Git is smart enough to actually tell you that there's a renaming, but we'll just confirm that by doing a du -c. E614 already existed. E2 existed, eb did not exist. So just one file has been created now. And if you do a git cat file on that, basically I want to print this content out. So that says renamed file, and nothing else has changed pretty much. But that's quite strange because I expected a change in the directory. So this commit is going to tell me where it's pointing to. So 1449 is what I have here. So git cat file -p blob youtube.txt. Okay. So that directory has changed. All right. Let's just confirm if that was the case earlier. Earlier we had E6, 14, E2 before we did the first commit, and 14 E0 was the content of the file. Now we have 1449. Oh my god, this is such a rare incident. I mean, basically what happened is you hashed the file, the tree object, and two tree objects came to the same bucket. That is highly unlikely. Okay, because you have like 62 characters per possibilities per character, so that's huge. It's like 3,600 possibilities. We found a tree which hits the same bucket. But yeah, it's not like we can mine bitcoins just yet because that's much smaller. So the probability of this was okay. But yeah, youtube.txt is what we have, and we have a new commit also. So in fact, if I just go here, E690, so let's do a ls on that. So .git /objects 14, and you see that there's two files over here. Okay, so no magic yet. Okay, so we have answered that question. Renaming files actually doesn't change the content of the file, therefore there is no change in the object itself, in the blob itself. So renaming objects in Git that's why fast, right? And that's one of the advantages of Git. It doesn't actually make you write the file again if you have just renamed it. Okay. Another interesting question is, what happens if I make a small change in a file? Yeah, if I make a small change, like I add a dot to the end of a huge object, let's say I have a video or something, which is 300 GB, and I add a dot to the end of the 300 GB, and then I save it, I add it to Git. Okay, so there is a change, yes, but the change is very small. What does Git do? Does Git create an entirely new object for this, or does it use the diff of the object? Okay, there's answers which are saying delta, it will use diff, yes, new object. So there's both answers. Okay, most of you are saying diff, right? Which seems to be the smart thing to do. Vinay Bhatt is saying that you'll use a new object. Perfect. Both of you guys are right in different situations. Let me just show that to you. Let's say I have some big file in my desktop, which is a photo of me. If there's a megalomaniac over here, then you can understand. I'm sorry, I'm going to copy it onto this directory. So we have youtube.txt and headshot.png. Now ls-la. The headshot file is of a reasonably large size. It's 1.4 MB, okay? But what I'm going to do is I'm going to add that file to Git. And du-c. Yeah, as you can see, the object at 01 has a file size of 2888. So that's a very large file. Okay, and what do I do with this? So I just want to like see the size of one, or rather I want to hash. So git minus cat file minus s objects .01 is that large file that we have, and right. So as you can see, the size is pretty big. Okay, and the type is going to be a blob object, and this is an image. Okay, now I am going to do something pretty stupid. I'm going to actually go to this massive image, and I'm going to, this is a PNG, and it's got lots of information here on the image itself, but I'm just going to go to the end of the file, and I'm going to add a dot for absolutely no reason. And as you can see, I'm scrolling down. This is very exciting. Okay, so let's head to the end, and I just added a dot. I wrote and quit the file. Git add, it's already been added. So git commit -am. So I'm just going to say image added. Okay. Oh, sad, isn't it? What happened is I added the file to Git, and it's made two large objects. So instead of taking the diff of the file, which most of us were hoping for, it's actually taken the entire file and put that in 7f, and also having the original file in 01, which is looks like a very silly thing to do. But the thing is, when you change the file in Git, the SHA of the file changes. Git has absolutely no idea what the SHA maps to. So a good hash function is very hard to reverse. You can't get the original contents back. So it doesn't know what to do with that different SHA. So it stores it in a different place. And therefore, you're having a lot of duplication over here. The memory requirements for Git can shoot up, right? This is not a great idea. And in fact, if you're using the network to pull and push files, this is a very bad idea, because you're doing a lot of duplicate transfers. Cool. So what do you think is the solution over here? In fact, I can kind of show you the git cat file. The size was huge, and if I do the same with 7f, which is the other big file, then it's going to be 3.5. Yeah, it's almost as big. Okay, this is not a great thing to have. So what Git does is very smart. It actually tells you that you can do garbage collection, or whenever you're pushing or pulling from the remote repository, it will compress the objects for you. So let's manually do that. Let's say git gc -- aggressive. So I'm aggressively going to collect all possible garbage in this Git project. And once I do that, it says delta compression is being used. It says that I'm counting the objects and I'm compressing the objects, and then finally I'm writing them. So now if I do a du -c, which is quite interesting, you're going to see that oh, okay, that's interesting. Why didn't it get rid of this file over here? An aggressive GC didn't get rid of it. Okay, so the duplication is still there on Git. It's created a pack file. As you can see, all the objects have been removed except that original object that we had. And the pack file is storing the content similar to this one. It's a very large file. But I'm actually surprised. This was not supposed to happen in this live demonstration, that you have two files of the same size. After doing a garbage collection, this should have been removed, ideally. So what I'll do instead is kind of change the file again, right? So vim, the headshot. I go again to the end of the file. This is weird, and I'll let you know in the comments why this happened. But the weird thing is Git didn't remove the file, right? It should have compressed things, but it didn't. So git commit -am, let's say modified the image, and I have done a little bit of insertion over here, and now I say du minus c, which tells me that there are 3 files which are large files. Now if I do a git gc minus minus aggressive, yeah, now let's see what happens. Okay, perfect. So earlier you saw that the total size of the Git directory was 8,896 bytes. Now it has compressed it to around 6,000 bytes. So earlier around 9,000 bytes, now around 6,000 bytes. What it's done is it's taken 2 files, the headshot with a dot in the end and a headshot with 2 dots in the end, and compressed them in this pack folder. As we can see, there's an anomaly over here which is not compressing the original file. So that's very interesting. Let's actually look into this pack folder, what's going on over here. So ls.git objects pack. Okay, there's 2 files over here. One is an index file and one is a pack file. Guys, I'll give you a minute to catch up. But these are the commands we have done till now. We have basically created a bunch of files, that is ls over here. 2 of them, we have updated them, we have tried to rename them, we have tried to add just a little bit of data to the end of a large file and see what Git does with it. The results have been very interesting. In one case, we have been able to compress the file. In one case, we have not been able to compress. So as you can see, instead of around 12,000 bytes in total, Git is now just using 9,000 bytes. Yeah. Yeah, Rishipal Singh has a good, I think, I'm not sure if it's a guess or if it's true, I'll just confirm that, but I have not committed the original file. That is true. And probably that's the reason why it has to hang around, because it can't garbage collect it aggressively right now, I guess. Guys, do you have any doubts up till this point? Okay, so we have seen how to add a file in Git, how to actually figure out what kind of database is Git using internally. It's a content-addressable system, also known as a version control system, because as you'll see, what it's doing is it keeps a graph of objects. One interesting thing, I actually committed stuff, right? So if you do a git log, I'll just head back to the webcam. Yeah. So if I do a git log, then it tells me that I have some commits. I have modified image as a commit, I have image added as a commit, and so on. So I'll just head to the modified image commit, which is this one over here. That git cat file what happened? So RB79, that's probably the thing. Git cat. Oh, okay, I forgot to add a -p. This is one of the silly things about git cat file. It should have a default, I think, of -p. But in any case, 7b f9 is telling you that the root directory is d1, d6, okay, and it has a parent. This is very interesting. So the commit that we are looking at, right, if you have a look over here, it's a type of commit. So the commit object has a parent object. What is that parent object? It's its parent commit. So if I just do a print of that, right, what we looked at was the modified image commit. And it's telling you that the parent is 3e6d, which happens to be image added. Okay, and it also has a parent. So the same command will work here, which is renamed file, that's the parent. And if I do the last parent of that, that is the first commit. So you can actually hop down the commit tree, right? And keep looking at all the commits this way. You just keep going to the parent. And this is quite interesting because if you have a merge in Git, it has multiple parents. The commit itself, the commit object has multiple parents. The very first commit has no parents. So you can see here, there's just the tree. There's no parent over here. Okay. Perfect. Now that we have the commit also understood, it's a graph. That's all we are doing. We are creating a graph inside our local storage, which is helping us track all changes in our code. As software engineers, we often want to see how did the code develop, or even more importantly, how do you revert any changes. Let's say you enter your, you go to office for the very first time. This is your first day at office, and then you screw up, which is something that happens quite commonly. It happened with me also, maybe. So what happens is then you want to take your changes back. So Git allows you to do that by just making you point to a different tree, a tree in history. So once you do that, your changes are gone. You are now pointing to an old piece of code which runs perfectly fine, and things are still working okay. Once you deploy that to production, yeah, you'll be fine. All right. Guys, if you have any doubts on the Git thing that we are doing, then let us know. Okay, Aditya Singh is just banned. Pure stupidity. Any doubts? Okay, fine. Also, I'm assuming that you guys are able to fire the commands, with me. So it's hard because I'm typing quite fast. But if you're not able to see this later on, you can watch this video. You can just jump to the point that you missed, and you can just carry it from there. Okay. So I just cleared the terminal, and let's start afresh. What I want to do is I want to look into this pack file, right? We had a pack file which has actually compressed our Git repository. So let's look into this. ls. Yeah, we have an index file and a pack file. So the pack file actually stores the data of the things that you have compressed, and the index is something very similar to a database index. That's one of the reasons why I like to think of Git as a database, as a version controlled database. All it has is a bunch of events, which is commits and addition of files, which creates changes in the database. All objects in Git are immutable. The reason being that you want to be able to see what's going on in the past and in the future. So when you make it immutable, you're not worried about losing changes in Git, right? And that's it. That's all that Git is. It's just a little bit of fancy processing over a database. Yeah. So let's head back to the code again. I'll just remove this. Yeah. There's a command to view what's inside a pack file. It's called git verify pack. And if you do a -v, it prints verbosely. Okay, so git verify -pack -v. We are going to be reading this pack file. Boom. Oh, okay. That's because the file, the directory I'm in is not the pack file directory. Yeah. So pack cell. Okay. This seems like a mess. I'll just try to improve it a little bit. Okay guys, I'll just try to improve this a little bit. Give me a few seconds on this. I want you guys to be able to see what's going on inside the terminal when I actually type this out. Yeah. Perfect. So this is what I have. I have done a verify pack on the pack file. And the pack file is telling me that I have a bunch of objects inside me. 4 of them are commits, 3 of them are blobs, and there's a few trees also inside. So what it's saying is that I have taken all these objects and I've compressed them. But the interesting thing is that this object over here, 7f35, is that big, massive object, which is the cat file -s. It's that big object, right? But have a look at 7f. Now it's saying that it's right over here. This object is just 55 bytes long, while this object 2bb59 is a huge file. So Git is saying that both these files are of similar size. They're both massive, but the pack file is telling me that this file is massive, but this file is really small. 7f is really small, and the reason for that is because we actually have compressed the file to 55 bytes, and we have taken the difference. So that's obvious over here in this bit. 2bb5 is my parent is being told by 7f35. So inside the pack folder itself, you have another graph which says that I am a file, but I may have a parent who I am pointing to, which provides the diff of me versus them, okay, which helps you compress files. That's it. So pack files are actually making your storage requirements lesser. It's able to let you do more with lesser space, and also across the network, whenever you push or pull any file, this is what you want to do, right? So that's what the pack file is doing, using a graph itself. And I'll just prove it to you. There's this thing over here which tells you that 7f35 is actually, I have just printed that out. Yeah, the sizes are the same, and we have just used this graph structure to reduce the content. Perfect. Now we have actually looked deep into Git. We know how a pack file works. We know how the objects are constructed. We know how the database is working. Next, let's see how branches work. Okay, so I'm on the master branch right now, but I want to make a feature. So git checkout -b, my feature. Okay, yeah, I've switched to a new branch, which is my feature. Now, if I actually say which branches do I have, I can just run this command ls -la, git references heads. In fact, why should I just jump to a tc -u, du -c, yeah. So Git has a bunch of references, and those head references are what I want to see. So ls heads, it tells you there's master and there's my feature. Okay, and if I say what's inside my feature, nothing. And there's nothing inside my feature. Of course, that's because my feature is actually not a directory. It's a file itself, right? Let's cat that file. So cat this file, and you have this huge number over here. Okay, what is this 7b49? Let's see. Git cat file -p 7b49. I think it's a commit. So not a valid object name. That's very, very odd. Okay, I've created my feature branch, and it's telling me the branch has been created from head, but this is odd because 7b. Okay, let's do a du minus c again just to see whether I have missed it or not. Oh, perfect. I think 7b F9 was what was that. Oh, okay. So that was a typing error. That's why you should always use copy paste. And as you can see, this is actually a commit, right? The type is commit, and you have the modified image being pointed to by my feature. So now if I say that I want to make a small change, so I want to say touch first file dot text git add first file git commit added another. Now if I print what's going on in my feature, the feature has changed, right? It's actually pointing to something new now, b034. So git cat file will give me what's going on there. Yep, added another. So it's pointing to a new directory. For Git, that is like a directory, like it's a tree object, right? Perfect. So what we are seeing is that every branch that we create is nothing but just a commit object. It's a pointer to a commit object. That's why it's called a reference. Yeah, it points to a commit object, which in turn points to the root directory of the version of the Git project that you're in. So branches are quite simple to understand, and if you create a new branch and you go on making commits, then obviously your branch ID changes, your reference changes, and in master, let's have a look at master. You're still pointing to an old commit, so latest commit is right here, 7b49, yeah, and then it also has the parent commits over here. Okay, great. So till this point, if everything has been clear, you can take a minute. We will again resume at 9:55, 2 minutes for just catching up with the commands and figuring out how a new reference is made. We call them branches, but for Git, they are references. We call stuff commits, trees, files, but for Git, they are nothing but objects. Yeah. And the addresses for us are basically links to a folder and stuff, but for Git they are just objects with the SHA. So the link itself, the file name itself is the link. That's all that Git is. After this we'll get to rebase. So I mean, how does rebase work in Git? So that might be quite interesting. In fact, a lot of people screw up in rebase. Yeah, it's interesting to know about it. Yeah. So 2 minutes, guys, till you can just type the commands on your own terminal and kind of catch up. Okay, Mohit is saying, are you going to private this video afterwards? Please don't. No, I won't private it. It's a live session, but that doesn't mean that I'll take it down. It will have certain sections which are, for example, right now, there's nothing happening, yeah, for the next minute. But I think these live sessions are useful, especially now when there's a lockdown. You might want to spend, let's say, an hour every day just figuring out how software engineering tools work, because when you will get back, when you join your company, your very first one, you want to be well prepared. So I was thinking of actually starting a classroom session like series, which is going to ramp people up on that aspect. Git is one thing I have in mind. There's also code reviews is another thing. Let's see who I can get on the channel for that. That will be quite interesting. I haven't asked Rachit Jain yet, but you can probably message him and tell him that, hey, would you be interested in a code review with Gaurav? That would be interesting. It's very important when you're working as a software engineer. It's one of the most time-consuming things, let's say, and you're expected to do it well. So there's system design, there's an expectation that you know your time complexities, there's an expectation that you understand the tools you're working with. Git is a common tool, and also, of course, the ID you're working on. But the ID, I feel like you can get a hang of it pretty quickly. Git is a database which has a lot of stuff going on under the surface. So a lot of people use Git, but they never understand what's going on inside, which is one of the reasons why they can't create a new version control system if it comes to it. So, which is a shame actually. I don't like using tools for years together without understanding what's going on inside. Maybe I'll have to eat my words later with Adobe Premiere, but yeah. Okay, it's 9:56, guys. Let's head back to the coding bit. Yeah. So the terminal is on, the webcam is off, and what we are going to do is we are going to figure out how rebase works. So Git rebase is nothing but change the history of the project I'm in. So if I do a git log, yeah, this is a log of all the commits that I have done till now, and I can see that there's a few commits like added another, modified image added, and so on. So this guy really needs to be fired, whoever this guy is, because he sucks at naming. But you have rebase which can fix this. Okay, let's say you really named your commits horribly and you want to change the names of the commits. So git -- rebase. Git rebase is the command. You want to make it an interactive one, and you want to say that I want to go back 3 commits from the current commit. So head is the current commit, and go back 3 commits. Sorry, there's a tilde over here. Yeah. Okay, so I don't want modified image and I don't want added another, but image added makes sense for me. So I just say pick the commits I want to. I can actually edit stuff, I can squash stuff, and I can fix up. This is basically just a squash but without the commits log message. So that's actually what I want to do. So let's do that. F over here and F over here. Now you're seeing something that I'm rewriting the history of Git. So if the commits earlier pointed to, these are commits, right? These are commit objects. Where are they going to go? Let's see. So you right quit, you have successfully rebased. If I do a git log now, you see image added, renamed file, and first commit, right? So modified image and added another are gone. So I've just changed the history of Git. But if I do a git gc -- aggressive, okay, now dc -u, the u - c rather, we have the pack file and everything done, but it shouldn't be having the old commits. But yeah, you can see basically your history has changed, right? So that's pretty useful if you want to change your history. Now I am not a fan of rebase. I think it no longer belongs in the software engineering field, according to me. But there's a lot of people who are really interested in keeping the history maintained through Git. So they want to see a commit and they want to see the next commit and they want to figure out how did the project evolve through Git, which is fine. You want to see how the project evolved, that's okay. But there are other tools for that. But this is useful. Git Rebase Interactive can actually let you change the history of Git. And there's another use case where Git Rebase can come in handy. So what I'll do is I'll just start a video, right, which you can view. and that will explain how Git Rebase works. Nothing to worry about. I have actually shot this video, so yeah. Okay. Yeah. Okay, this is weird. Uh-huh. So all the commands that I have actually put over here are in this video, but you can of course see it in the YouTube live session itself. In fact, I think I'll put this video up as an unlisted video in the description itself, so that will explain Rebase much better instead of me setting this up and trying to do this live. So I'll just get back to the webcam. Yeah. Or maybe I can take it in the next session. It's been an hour anyway. So guys, do you have any doubts? We can talk about Rebase next time or something, but do you have any doubts on the current video that we just took? Like the stuff we did on Git? You might feel like most people, when you see this session is, what the hell, you just made Git more complicated, or you went into so much detail. I wanted to know how I can use Git instead of how Git works. But believe me, I have seen engineers starting with, just tell me how to use it and get away. I'll get away from how it's working, versus engineers who go like, oh, how's that working? Maybe not immediately, because there's everything to learn in life. So they don't attack every problem with, I need to know up to binary how the thing is working. But when they get the time, they go and they read about how does that thing work internally, which helps them long term. So this is a detailed video, far more detailed than the original. Hey, git push, job done. Git pull, oh, you have a directory. Git clone, you have a new project. Those things are trivial commands. Yeah, those things are called post lane commands in Git. Basically, they wrap a lot of complexity and give you a nice abstraction, while these are called plumbing commands. So if you're creating a new washroom, let's say, you have the nice tiling outside and you have the plumbing, the real engineering work going on inside. These are plumbing commands. I think we'll just end the session in 2 more minutes, guys. If you have any doubts, then let me know. Oh, there's back-to-back SWE. Hey. So Tushar Srivastava is asking a question which is quite interesting. The video will be on the channel. If you guys joined midway, or if you guys joined towards the end of the broadcast, that's fine. This video will be on YouTube. It will be not unlisted also. It will be public. Whoever wants to know about the Git internals, you can actually share this video with your friends and they can watch it at 2x or something, or just skip the parts where there was a lot of talking, because you need that for a live audience. You need people to catch up. But you can do this actually in your own local terminal and you'll get the same SHA hashes, because the content has not changed, right? So that's how you can be sure that this will work. Okay, Rishipal is saying, it seems that if you modify the files before committing, a new object is created, but if you modify after committing, just the delta is stored. That's not true actually. That's true, not technically. When you commit the file, it's not going to be storing the delta. It's going to be keeping the original files. But when you do a garbage collection, which runs automatically whenever you're pushing or pulling from the remote directory, that is when the files will be compressed into the pack file, and that will be stored in your local storage to save space. Local storage actually you don't care about. You want to reduce the bandwidth requirement when you're sending a project. Like if you have 300 MB, instead of that, if you can compress it to 10 MB, that's a big saving. When it comes to sending across the network, local storage like 300 MB, what's the big deal? Okay, guys, last minute. Vipul Mangotra, session on using Git through IntelliJ I. Okay, so yeah, these were the final thoughts. I forgot to tell you this. If you want to use Git or any software and you have some stuff which is helping you, which is making your life easier, like IntelliJ, any IDE which is helping your life easier, helping make your life easier, do that. Okay, the terminal commands that I showed you, that's not how you add files in Git as a software engineer. You can do it in a remote box where you have no other choice. But if an IDE is giving you the safety of a correct command, the ease of use and all that, then always use an IDE. Never go and start typing commands over here and check out the objects except for a play project. Yeah, it wastes so much time. And a lot of people I've seen git checkout -b new branch. Well, why are you doing that? Use the IntelliJ program. Yeah. Another thing is, if you want to use Git for history, I don't think it is a good idea. The main reason being you're coupling code with your history. Yeah, this is a business use case. The reason you want to read this is not so much to see the history of the code, you want to see the history of how a system developed, or you want to revert to a particular point. This is different. This is code. Yeah. So you can use a tool called Arcanist. I'll post all these things in the description. And that actually allows you to decouple code from history. I'll just show it to you actually. Arcanist Fabricator. Let's turn on Chrome. Yeah, this is what I'm talking about. What this does is you have better ways to review code. You have better ways to share code basically in your team. Git still handles the low-level database thing, but Arcanist is built on top of it, which helps you do reviews better, and it separates out all that thinking of how should I name this commit. Like, screw the name of the commit. Just focus on writing good code, committing things, and finally, when you're making a difference, when you're actually pushing to master, that's when people will see the change and they'll either accept or reject based on the quality of the code, not on the history of the code. Okay, guys, I think we are done. Thanks for tuning in. There's like 300 of you guys who remained. Initially, you guys were like 600 or something, but it's always shocking to me that so many people sit down and talk about Git and listen to it. Thank you for tuning in. Thank you for trying out the commands locally. I'll see you soon. Most likely the next live session is going to be on code reviews. I'll try and get somebody to review my code, or I'll review their code, and we'll talk about what are some good practices over there. The whole idea of this playlist, this particular playlist that I'm making, is to prepare people who are entering the software engineering industry or who want to like be good software engineers. So these things are essential. Good code reviews, understanding Git, and a few other topics that I've actually noted down. So we'll get to that also. See ya.